Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing on with AP Physics Kinematics problems. And so here is the next one. Now, I want to encourage you guys to just sort of pause the video, read the problem, try to do it yourself. And then after you've tried or you struggled or you finished it, come back, check your answers, or see how I did it. Okay? So in the Star Trek reboot movie, young Kirk drops out of a Corvette speeding at a velocity v0 towards a cliff. Yeah, he jumps out of here. I remember this. He was taking his uncle's car out for a joyride. A robot cop was chasing him, and the car was heading over to a cliff. Young Kirk slides along the ground and travels a distance d equals 5 meters before stopping right at the edge of the cliff. The car flies off the cliff after falling a height of 50 meters and hits the ground at a distance 30 meters from the bottom of the cliff. What is the coefficient of kinetic friction between young Kirk and the ground? The velocity v0 is not known but can be determined, and assume the car did not slow down after young Kirk dropped out of it. I would strongly recommend that you do not put numbers until the very end of the calculations. Okay. So we're going to assume that while he's sliding, he's feeling a constant acceleration, frictional acceleration, okay, from the frictional force. So they're saying I need to find the initial velocity. So I know that this is 30. Well, I know that he's saying not to do the computations. If I wanted to figure out how fast this car was going off the cliff, and hence how fast Kirk was when he jumped out of the car, I have to know this is v0, and I want to solve for what v0 is in terms of these variables. Now, I know in the x direction, the distance, it would be delta x is equal to v0 t plus 1/2 at squared. The displacement in the x direction is d, so d is equal to v0 t plus 1/2 at squared. Now, v0 is what I'm trying to solve for. The acceleration is 0 though in the x direction, right? Because we ignore kind of air resistance and everything. So d is really equal to v0 t. Okay, so I can solve for v0, it's equal to d over t, but I don't know how long it was in the air for. Like, it depends on how long it was in the air for, and that's when I look at the y direction. Usually for knowing how long something is in the air, it's the y direction that dictates it. Again, I'm going to use this equation, delta x is equal to v0 t plus 1/2 at squared. But now let's consider the displacement. The displacement is going to be h in the vertical direction, because I'm doing in the y direction, the vertical direction. His initial velocity in the vertical direction is 0, because all of his initial velocity is horizontal. So he's got 0 in the vertical direction. Plus 1/2 g times t squared. So the time, solving for t, I can multiply by, I get 2h divided by g and take the square root of that. Okay, so if I can plug this in and solve for v0. V0 is equal to d over t, which is equal to d over the square root of 2h over g, which is really d root g over 2h. Okay, so that's his initial velocity. So Kirk slides 5 meters. So he jumps out of the car right before it flies off, right? He's jumping off, and this is the velocity it's going. He slides a distance d meters, okay, and he's under a constant acceleration. So I would think of Kirk as let's see. There's two equations that relate displacement and acceleration. I can either use this equation, vf squared is equal to v0 squared plus 2a delta x, or I can use this equation, delta x is equal to v0 t plus 1/2 at squared. Thing is I don't really know what the time he took to slide was, and I don't really need to know that. So I'm going to use this equation, and let's see if I have enough equation. Vf is his final velocity. He had to have stopped, otherwise he would have fallen off the cliff. v0 squared is this part, so it's d root g over 2h, right? Because it's how fast the car was going. Plus 2a, and his displacement was delta x, or d, little d. okay, the 5 meters. So I can solve for A, right? I can say negative 2AD, bring it over here, is equal to D squared G over 2H. And then A would be equal to negative 1/2 D squared G over 2HD, because I'm going to divide by D, divide by negative 2. Okay? So this is negative 1/2. Big D is 30. G is 9.8 meters per second squared. 2. Oh, this 2 and 2 I could have made 4. But H is 50 meters. And D is 5 meters. And so let's look at the units just to make sure I have. I have meter squared, meters cubed over meter squared. That's meters. Meters per second squared. That is acceleration. Okay? And I'll use a calculator here. Do 30 squared times 9.8 divided by 50 divided by 5. Got negative 8.82 meters per second squared. Okay. What is it? Oh, okay. So that's the acceleration. That's not what I'm actually trying to find. I'm actually trying to find. That's A. Okay. But I know that the frictional force would be the net force on him would be mass times acceleration. So I just have to multiply this. So I have MA. It's also equal to mu k times the normal force. The normal force in this case would be mg. So mu k is equal to A over g. So that would be equal to negative 8.82 meters per second squared divided by negative 9.8 meters per second squared. And so the coefficient of friction would be 0.9. Okay. So I hope you guys found that helpful. Yeah, I think I finished that problem, so I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.